Hello everyone, my name is Kaan and I'll be talking about the Verifier Alliance today and as well as some info about Sourcify, the project I'm working on. Sourcify, if you haven't heard about it, is a source code verification project. It started as a side project of the Solidity team, the smart contract language Solidity, and now we are on our own project inside the EF. So we are a public good funded by EF, let's say, and not a company and so on. Right now we are a decentralized and open source smart contract verification service. We are 3 people, Manuel, Marco, and I, working on it. And as I said, we are a decentralized and open source smart contract verification service. This kind of assumes there is a counterparty to this, that there is centralization and closed sourceness in the ecosystem. And it is because of, currently it's not decentralized and open source, it's because of this. I guess everyone in our ecosystem so far knows Etherscan. And these days I'm talking to some people and talking about Sourcify and smart contract verification, and a lot of people think Etherscan is a public good and it is open source. No, it's not open source, it's not a public good, it's an insanely profitable business. Not that they don't provide any value. I think Etherscan brings incredible value to the ecosystem, and they are just basically the go-to place to know what's going on the chain. But still, they are a company and they own all the data. So our general thesis, like what we think is this does not align with the ethos of the ecosystem. Before we go into what Sourcify does and what the Verifier Alliance that I'm talking about exactly is, let's recap what's smart contract verification. So the problem the smart contract verification solves is that contracts on the chain lives as a bytecode. So when you go on chain, want to see what the code does, this is all you get. Like the binaries, the zeros and ones is all you get from a smart contract. And this is obviously not human readable. By looking at this, you don't understand anything what your contract you are about to interact does, and you are basically going to give money to this code. So I guess you should know what it does, or at least someone that knows what's going on should be able to look at it. And I can say, for example, this contract is my source code. Like I can say, okay, the source code of this contract is this. But then how do you know? Like how do you know this GitHub code, like the code that I copy pasted and sent you, is actually the code behind everything? Because it's in reality, it could be like stealing your money or doing some other stuff. At the end of the day, what we want to see is the human readable Solidity wiper or other human natural language written code, and this check mark that is green and verified, and this will make you happy. So how does it work? We first have the source code, contract source code in different files. Let's say we have these Solidity files here, my contract sol, ownable, ERC20. In addition, we have the compilation settings here. It might be difficult to see, but it's basically the compiler version, the optimizer settings, and other options you give to compiler that will affect your compilation. And then we feed this into the compiler, the Solidity compiler. And this gives us a bytecode. This gives us the bytecode from these written contracts. Then we have a contract that is on-chain that we want to verify. So let's say we want to verify the contract at this address, and the on-chain contract itself also has a bytecode. So on the left side, we have the one we compiled ourselves from our smart contract verification service, and on the right side, this is taken from the on-chain data. Like this what lives on-chain, and we compare it. Like, do these bytecodes match? And if it's a match, we say these files are the source code of this contract at this address. So of course it's simplified, but that's the main idea behind it. And how does Sourcify solve this problem? What is our approach? As I said, the current status of smart contract verification is closed source and decentralized. So obviously the whole code of Sourcify is open source. And another thing that is possible is you can run your own Sourcify. For example, this is HashScan from the Hedera chain. It's one of the most popular block explorers of Hedera chain. And HashScan, Hedera itself, run their own Sourcify, for example. Instead of their writing everything from scratch, they basically fork Sourcify and they're running Sourcify themselves for smart contract verification. So it's open source. So you can both run your own Sourcify and see what's going on and why it's not compiling, why it's not verifying. If there's a bug, we can fix it together, we can document it, and it's publicly available. Secondly, it's decentralized in the sense that it's served, all the contracts we have are served on IPFS. And IPFS also brings us a nice feature that we do something differently. So besides the other verification services, Sourcify does something we call a full or a perfect match, which is the bytecode plus the metadata hash match. What is the metadata? What am I talking about here? So Solidity compiler by default appends a special field at the end of the bytecode. So this part is the functioning bytecode, and this one was added as a metadata at the end. Yeah, and this is the hash of metadata. So the part here, the black part, is the functioning code. So this is like what executes. And the later part, the last part, is the part that does not execute. This is just metadata. And this metadata contains something called Solidity contract metadata. So it's an IPFS hash, and if you resolve it, you get a JSON file that contains basically two information. One, how do I interact with this contract? The information like ABI user.dev.doc, and how do I reproduce this contract compilation? So the compilation info and the source file info. The file looks like this. So you have the compiler version, the language, then in the output you have ABI user.dev.doc, and below that you have the settings. So the compilation targets, the compiler settings part, and below here you have the source file info. So you have the source names, the source, sometimes the source code itself can be embedded, but also we have the IPFS hashes of the sources. So the full verification then makes sure that what you see is 100% what was compiled. So I'll go with an example how this works. So let's say we have these contracts, my contracts all, and I make a small difference in the contract. I add a comment, I change the variable name, anything that does not affect the functioning code. Now we have this mycontract.div. Then the hash of this file will change, right? Because as I said, the source file also contains the Keccak hash of the contract, the source code, and also like IPFS hashes. So the hash of the file will change. In turn, the hash here will change inside the metadata file, right? And then in turn, the whole metadata file has changed, and the IPFS hash of this file will change. So in this case, the whole thing here will completely change. So we say, okay, like this part does not match. So this contract code you are seeing is different than exactly what it is. If you want to play around more about how it works and what it does, we have a playground. If you can't see it, it's playground.sourcify.dev. We have some example contracts, and we break down everything that I have shown here in more detail. So if you want to see contracts and how all this metadata hashes and everything works, you can check it out there. Yeah, in short, Sourcify now is supporting 152 EVM chains. Don't ask me what these chains are. We just accept everyone if they want source code verification. Yeah, you can see which chains we support on our docs page. You can verify through our UI. We have an API, and you can also import contracts from Etherscan. We have hard hat support, so if you're using the official hard hat verify plugin, you can verify your source code by enabling Sourcify. It's unfortunately disabled by default, but we're working on it. So you have to enable it. If you want, for example, if you have a custom Sourcify, you can give the custom Sourcify URL and on your local or somewhere else, and you can easily verify your contract by hard hat verify network and the address. There's Foundry support, so if you're using Foundry, you can pass the verifier Sourcify flag, and again, if you have a custom URL on local, for example, you can pass this info, and this will send your contract to verification to Sourcify. And we also have a Remix plugin, but we are also now working on a new plugin, a unified verification plugin that will allow users to verify on all verifiers. Let's say you have a contract, you want to verify it behind the scenes. This will verify everything on Etherscan, on BlockScout, on Sourcify, because I believe like the contract verification should not take place in one place only, and it should just in parallel go to everywhere generally. So we are working on a unified plugin for all verifiers. But we can't solve this by ourselves. This is quite a big problem. We need ecosystem-wide collaboration with this. That's why we as Sourcify and other projects started what we call the Verifier Alliance. So with RouteScan, Sam helped us quite a lot as well. BlockScout, Sourcify, Tenderly, Dora at the moment. We have found this Verifier Alliance to tackle the problem of smart contract verification and the openness of the data. So in short, Verifier Alliance is an ecosystem collective aiming for easy, unified, and open access to source code of EVM smart contracts. Because as I've talked about the problems, currently it's closed source, the data is difficult to access, and it's not standardized. And what we want to do is actually a really simple thing. We say, like, what if we took everything and put it in one place? That's the basic idea. Is quite simple. Of course, there's a lot of coordination effort behind everything, but yeah, we just want to put everything somewhere and make it really easy to access and open. We have how it works is Verifier Alliance is not a verifier. It's like a unified. It's a place that your verification goes. So you have to go to a verifier. You go to Sourcify, you go to BlockScout, you go to RouteScan, and you verify your contract there, and your contract will end up in this shared database. So everyone will like collect what they have in one place, and yeah, this data will be filled by these data providers. And the database schema is also available at our GitHub. It's Verifier Alliance database specs. In short, without going into too much detail, it looks like this. It's an SQL database, which basically decouples the contract deployments from compilations. So a verified contract is basically an association between a deployment, a contract on chain, and the compilation. So we say this compilation matches this deployment. So yeah, as I said, we decouple the compilations from deployments. There's a runtime code match, and there's a creation code match. So runtime code is the code that is running on chain, and the creation code is what's produced by the compiler, so we can verify on those both. And we normalize the bytecode and add transformations. Like, what does this mean? The transformations are what we call are the edits on the bytecode before everything goes on chain. So like things such as libraries, immutables, CBAR aux data, these are not the functioning bytecode, but other things added to the bytecode. Let's give an example. For example, this is a creation bytecode transformation, because how do I know this? Because there's a constructor transformation, and this means a constructor argument has been inserted, like appended at the end of the bytecode to the code. So that means there's a compiled code, and then on this compiled code, we replace the metadata and we added these constructor arguments. At the end, we have the code that we verify against. So this is also a runtime code transformation. Here, for example, we have replaced a library address, a library contract that this contract uses, or the immutable variable, its value. So we say, for example, for this case, if this is the compilation output of the runtime bytecode, you can see the green field is the library address placeholder. What color is this? Like the one in the middle is a immutable variable placeholder, and this is the field I shown you on the metadata field. So the compiled output becomes this on the on-chain contract. So if we apply these transformations, the compiled output will become this, and we say, okay, and this code will match the on-chain code. That enables us to have a base contract, and you can apply a bunch of transformations on top of the base contract and verify different addresses with the same contract. So if you deploy the same contract on a different chain with different values, you can use the same contract. Let's say we have a Uniswap pool on different addresses, so we can use the same base contract by applying different transformations everywhere. Yeah, and the of course, I forgot to add this place, the normalization basically removes all these stuff. So it creates a base contract for applying the transformations on top. So yeah, the database right now has around 900,000 verified contracts, and it's growing. It's not only a database, it's also a shared knowledge place where all the verifiers can collaborate and exchange information. We want to have test cases, we have to have certain edge cases tested and document the information, the knowledge we generate basically. And it hopefully will be a place for tooling around the standard and the schema that we are creating. And on top of the data, like so many things can be done. Like this data is missing, and both for data analysis purposes, like you can do some security analysis when there's a vulnerability, or for example, what you can do is you can do a bytecode similarity search. For example, if you have a contract on one address and it's not verified, by looking at this database, you can say, okay, like this contract is 98% similar to this contract, so it might actually be this one. So there's a lot of things that we can do on this data. Yeah, right now the database is growing. We really want to share this database publicly in Parquet format soon. Actually wanted to share it this week, but unfortunately we have spotted a mistake inside the database, so it's a bit delayed, but really soon. And maybe even in the future we can add an API or application access for people to just pull data. But for now it's just a database, and it will be just a database dump, because running an API, a public API, is a bit tricky. It requires much more effort. So yeah, that's mostly it about the Verifier Alliance and the Sourcify. You can check out the website, and from the website you can reach the GitHub and the Twitter. We also have a public chat, community chat, if you want to reach us out. And yeah, this is also how we can reach Sourcify. And yeah, that's it from my side. I'm happy to take questions.
Awesome. Do we have any questions?
Any questions?
Well, actually, I do have a question.
Sure.
I would like to know, because I can imagine there are cases where the verification can be super valuable. So is there any incentive for the validators, or to create a pool of validators specifically dedicated to verifying contracts?
Validators?
Yeah, the verifiers, sorry.
So the verifiers are Sourcify, Blockscott, and another block explorer. And what is?
Yeah, so I guess I'm trying to ask, like, what was the insight? Like, how can we get more people to be interested in this, to maybe want to fork? You know, what? I mean, other than just saying, hey, we need this, but like, what would be the incentive for an ecosystem maybe beyond just
Yeah.
transparency?
I mean, I think the basic incentive or let's say force should be the community voice. Basically the users, the community members should be pushing these tooling and other people that have verified contracts to contribute to this place. And we also know who really we want to push this for. I guess our big guy. Scan also would be nice to have. But yeah, basically just the community members should be pushing this. And this should be a natural thing to do because the source code verification is the basis of every single thing that we take for granted on blockchain, like trustlessness, open source. All of these things are based on the assumption that the source code is available and verifiable. And I see it as a no-brainer that everyone should be opening up and sharing this data.
Awesome, thank you.
Hi. So I wanted to ask about when you verify, do you trace the construction transaction entirely and also compare, since the constructor doesn't end up on chain, do you verify that it's identical to the one in the source code and metadata?
Mm-hmm. Yeah, this is a good question. So at Sourcify, we try to trace the RPC for the creation transaction if it's available at the RPC level, like it's an archive node that we can look at the traces. But basically, the problem here is the runtime code is on-chain and it's fetchable from an RPC, but the creation code is not there. And I see this as a centralizing force in the ecosystem because you basically need to index the chain for the creation bytecode. And that's quite difficult for doing for every single chain. So what we do, at least as Sourcify, is we check the transaction that created the contract and try to get the transaction.data, like in the payload of the transaction, if it matches the creation code. But then also if we look, if it's a factory contract, if the traces are available, and if not, we just have to skip it. And at least Sourcify's end. Maybe I think Blockscott does it probably Etherscan does it as well, but we personally, as our project, we don't index everything.
Yeah, I guess you would have, since it could be a factory, you would have to actually trace the transaction and see when the create or create2 opcode is being called, you need to see what it is called with, because otherwise you could have a very similar but malicious constructor. Let's say it sets something, it backdoors through the storage and then returns the same code. And the compiler would give you the same, the compiler for the source code without the malicious version could give you the same metadata. Like the correct metadata. So I think the only way is really to trace the opcode, the create opcode.
Let's discuss about this a bit more.
Sure.
Thank you.
Awesome, thank you. Do we have a final question? Well, if not, thank you so much for joining us, Kaan.
Cool. Thank you.